Welcome to our course Introduction to PLSQL. Procedural language or structured query language turned is an extension of structured query language used in Oracle databases. It allows for procedural constructs like loops and conditions, enhancing structured query language's capabilities. Understanding procedural language structured query language is crucial for database management and application development, providing robust error handling and improved performance. The course comprises 15 lectures and 6 lab sessions, focusing on practical and theoretical aspects. Assessments include midterm and end-of-term written exams, culminating in a comprehensive final exam. This structure ensures a balanced approach to mastering PLSQL, combining hands-on experience with rigorous evaluation. SQL, or Structured Query Language, is essential for managing data in relational databases. It includes DDL for defining structures, DML for data manipulation, DQL for querying, DCL for access control, and TCL for transaction management. Mastery of these commands is crucial for efficient database operations. An HRER diagram visually represents the relationships between entities like employees, departments, and positions. It defines attributes such as employee ID, department name, and position title, illustrating how data is interconnected. This diagram aids in understanding data flow and structure within human resources systems, ensuring efficient data management and retrieval. Data definition language, DDL, is crucial for defining database structures. It includes commands like create, alter, and drop to manage tables and schemas. Create establishes new tables, alter modifies existing structures, and drop removes them. Understanding DDL is essential for efficient database design and management, setting the foundation for data manipulation and integrity. Data manipulation language, DML, is crucial for managing data within databases. It includes commands like insert, update, delete, and merge, allowing users to modify data efficiently. These operations ensure data integrity and facilitate dynamic data handling, essential for maintaining accurate and up-to-date information in any database system. Query operations are essential for retrieving data from tables, producing a result in table form. This result can be further manipulated using additional query operations. SQL's select command is pivotal, with a basic syntax of select attributes from tables, where conditions enabling precise data extraction. The select statement is fundamental in SQL for retrieving data. For example, select from regions R, where R region ID SAR1 fetches all columns from the regions table where the region ID is 1. Similarly, select from regions R, where R region ID is 0, retrieves all regions with a non-negative region ID. The SQL queries retrieve data from the regions table. The first query selects records where the region ID is exactly 1, while the second query retrieves all records with a region ID greater than or equal to 0. This demonstrates filtering data based on specific conditions using SQL. The SQL select statement is fundamental for querying databases. It retrieves data from one or more tables, allowing users to specify columns and conditions. Understanding its syntax and functionality is crucial for efficient data manipulation and analysis. Mastery of select forms the basis for more complex queries and database operations. Selecting the right option involves evaluating criteria such as cost, efficiency, and compatibility. Consider the long-term benefits and potential drawbacks. Analyze how each choice aligns with your goals and resources. This decision-making process ensures optimal outcomes and strategic alignment with your objectives. Selecting the right option requires understanding the criteria and evaluating each choice against these benchmarks. Consider factors like cost, efficiency, and scalability. Analyze data and feedback to make informed decisions. This approach ensures that the selected option aligns with strategic goals and delivers optimal results. Selecting the right option requires understanding the criteria and evaluating each choice against these benchmarks. Consider factors like cost, efficiency, and scalability. Analyze data and feedback to make informed decisions. This approach ensures that the selection aligns with strategic goals and maximizes potential benefits. Selecting data efficiently is crucial in database management. Use the select statement to retrieve specific columns from a table. Employ where clauses to filter results and order by to sort them. Mastering these techniques enhances data retrieval performance and accuracy, setting the stage for more complex operations. Nested queries or subqueries are queries within another SQL query. They allow for complex data retrieval by embedding one query inside another. This technique is useful for filtering, aggregating, or transforming data based on the results of another query, enhancing the flexibility and power of SQL operations. Transaction Control Language, TCL, manages database transactions, ensuring atomicity. A transaction groups tasks, completing only if all succeed. Key commands include commit, which saves changes, rollback, which undoes changes, and save point, allowing partial rollbacks to specific points. These tools ensure data integrity and consistency in database operations. TCL or Transaction Control Language is crucial for managing database transactions. It ensures tasks are executed as a unit using commands like commit to save changes, rollback to undo them, and save point to create checkpoints. These commands maintain data integrity and consistency, especially when tasks fail, ensuring reliable transaction management. SQL is powerful for data retrieval, insertion, and database object definition. However, it lacks capabilities like using variables, loops, and conditions, handling errors, and executing complex business logic. These limitations prevent SQL from executing multiple steps as a single program, necessitating extensions like PLSQL for more advanced data processing. PLSQL is Oracle's procedural extension of SQL, enhancing SQL with programming elements like variables, control structures, and error handling. It addresses SQL's limitations by allowing complex data processing and performance optimization. PLSQL transforms SQL's single-statement execution into comprehensive programs, offering developers a robust solution for intricate business logic. PLSQL is a block-structured language enabling organized code execution and variable scope definition. It supports anonymous blocks, which are unnamed, and named blocks like procedures, functions, or triggers. This structure enhances code modularity and reusability, crucial for efficient database management and application development. A PLSQL block can include up to 4 sections: header, declaration, execution, and exceptions. The header is for named blocks, defining how they're called. The declaration section sets up variables and sub-blocks. The execution section, mandatory, contains executable statements. The exceptions section manages errors and warnings, ensuring robust error handling. PLSQL blocks are structured with up to 4 sections: header, declaration, execution, and exceptions. The execution section is mandatory, containing executable statements. Headers define block calls, while declarations set variables and cursors. Exceptions manage errors. Understanding these sections is crucial for effective PLSQL programming. Anonymous blocks in PLSQL are executed immediately and are not stored in the database. They consist of an optional declare section for variable declarations, a mandatory begin section for execution statements, and an optional exception section for error handling. These blocks are ideal for testing and learning purposes. Anonymous blocks in PLSQL are executed immediately and are not stored in the database. They are ideal for testing and learning purposes, allowing developers to experiment with code snippets without affecting the database's integrity. This flexibility makes them a valuable tool for quick iterations and debugging. Consider a PLSQL anonymous block that calculates the sum of 2 numbers. Begin with the declare section to define variables, followed by the begin section to perform the calculation. Finally, use DBMS output put line to display the result. This structure allows for quick testing without permanent database changes. A PLSQL anonymous block is a non-stored code segment executed immediately. It begins with the declare keyword for variable declarations, followed by the begin section for executable statements, and ends with end. These blocks are useful for quick one-time operations without the need for permanent storage in the database. In PLSQL, an anonymous block is a non-named PLSQL code unit that executes immediately. It consists of 3 sections: declaration, execution, and exception handling. The declaration section is optional, while the execution section is mandatory. Exception handling is used to manage runtime errors. Anonymous blocks are useful for quick one-time operations without creating stored procedures. Comments are crucial for clarity in programming. They provide built-in documentation, enhancing understanding of complex logic. Procedural language structured query language supports 2 types: single line using ku and multi-line enclosed by o and u. These comments ensure that even intricate code remains comprehensible, aiding both current and future developers in maintaining and updating the code efficiently. Comments are crucial for understanding complex logic in programs. Even with clear structures and names, they enhance clarity. Procedural language, structured query language supports single-line comments, which begin with 2 hyphens, and multi-line comments enclosed by se and. These tools ensure that code is not only functional but also comprehensible. Comments in PLSQL are crucial for clarity. Single-line comments start with 2 hyphens, kin, while multi-line comments are enclosed between itkas and kin. They help explain complex logic, making code easier to understand and maintain. Effective commenting is essential for collaboration and future code modifications. To summarize, PLSQL extends SQL with programming capabilities, helps manage complex logic, and is essential for working with Oracle databases. Thank you for your attention.